Alright, so we will finish the chapter 3 practice test now, 3-5 to the end. So this one right here is like the same as order of operations, number 17. In order of operations, we first deal with the parentheses. I don't know if you can see that, but there's a parentheses where you're supposed to be subtracting those two matrices. So if we subtract them, we have negative 4 minus 0 is negative 4. 1 minus 5 would be negative 4. 2 minus 4 would be negative 2, and then we just need to distribute the 2 to each thing. 2 times those negative 4s would be negative 8s, and then 2 times negative 2 would be negative 4. Okay, number 18 and 19 is a little bit trickier because this is multiplying two complete matrices together rather than just a number outside. The first thing is we need to verify that this is possible. And the way that matrices work, the dimensions, you say them as rows by columns. So there's 1, 2, 3 rows, and there's 2 columns. So that's a 3 by 2, and this one is a 2 by 2. If these numbers are the same, which they are, then we can multiply them. And the dimensions of the new one are going to be these outside numbers. So the matrix, when I multiply it, the new one is going to be a 3 by 2. Okay, so let's just make a blank 3 by 2 matrix with 3 rows and 2 columns. Okay, and then how do we fill this stuff in? Okay, so this right here, this red one, that is the first row and the first column. So I'm going to take the first row here, multiply it by the first column right there. Negative 6 times 4 is negative 24. Negative 2 times 6 is negative 12, so I should add those together. Okay, then we will do the next one. So the next one is, this is first row, second column. So here's the first row, here's the second column. Negative 6 times negative 1 is positive 6. Negative 2 times 6 is negative 12. We'll add these together in just a sec. Okay, down here, this is the second row, first column. So there's the second row, there's the first column. 0 times both of those, when I add them, is just going to be 0. Okay, then this one right here, this is going to be second row, second column. So there's the second row, there's the second column, and again, 0 times all that stuff, when you add it, will still be 0. Okay, this last one is third row, first column. So there's the third row, there's the first column. Negative 2 times 4 is negative 8. 6 times 6 is 36. Okay, and then here's the very last one. This is third row, second column. So there's the third row, there's the second column. Negative 2 times negative 1 is 2. 6 times 6 is 36. Now all we need to do is add these together. Okay, so the top one, negative 24 plus negative 12 is negative 36, and 6 plus negative 12 is negative 6. Those should both be 0. And on the bottom, negative 8 plus 36 is 28, and 2 plus 36 is 38. Okay, this one right here, let's first verify that we can actually do it. Number 19, that is. This is a 2 by 2. This one has 2 rows and 3 columns. So because these numbers are the same, we can do it, and the new one is going to be a 2 by 3 matrix. Let me draw a blank matrix with 2 rows and 3 columns, just like that. This right here, this is first row, first column. So there's the first row, there's the first column. 3 times 1 is 3. 5 times negative 6 is negative 30. So let's change color here so we can see this a little bit better. This is first row, second column. So first row, second column, 3 times 6 is 18. 5 times 4 is 20. And then after that, we're going to move to the first row, third column. So there's the first row, there's the third column. 3 times negative 2 is negative 6. 5 times negative 2 is negative 10. And now we're going to the second row. So second row, first column. Here's the second row, here's the first column. 2 times 1 is 2. 3 times negative 6 is negative 18. After this, we have the second row, second column. So here's the second row, here's the second column. 2 times 6 is 12, and 3 times 4 is also 12. And then finally, we have our very last entry. This is second row, third column. Here's the second row. Here's the third column. 2 times negative 2 is negative 4. 3 times negative 2 is negative 6. When you add all of those numbers together, you should get what you see right there. So 3 plus negative 30 is right here. 18 plus 20. Negative 6 plus negative 10. 2 plus negative 18 is right there. 12 plus 12. And negative 4 plus negative 6. Okay, the last one on this page is a lead-in to Cramer's rule. And for Cramer's rule, what you have to do is find the determinant. The determinant is just the product of this diagonal. 2 times negative 1 is negative 2, minus the product of that diagonal. Minus negative 2 times 2 is negative 4. And that's the same as plus 4. and negative 2 plus 4 is equal to 2. So there's the determinant. Alright, let's do one more. The product of this diagonal, 1 times negative 1 is negative 1. It's always minus. And negative 1 times negative 1 is positive 1. So negative 1 minus 1 gives us negative 2. How do we use Cramer's rule? What we need to do is find three determinants. We have to find the main determinant, then we have to find the x determinant, and then we have to find the y determinant. And then our final answer is going to be x is going to be equal to the x determinant over the main one, and the y value, I should say, is going to be the y determinant over the main one. So let's find each of these. Let's start by finding the main determinant. And we find the main determinant by just taking these coefficients here, negative 3 and 2, and 2 and negative 3. And then we do what we just did on the other page. So negative 3 times negative 3 equals 9. Minus, it's always minus when you find the determinants. Minus 2 times 2 is 4. So 9 minus 4 equals 5. So that's the first number that we need. And that means both of these are going to be something divided by 5. Usually, it doesn't have to be this way, but usually these turn out to be whole numbers when you get your final answers. Whole numbers are at least fairly neat fractions, so sometimes that's a good check. Okay, dx, because we are finding the x determinant, we need to, by the way, these right here are the x's, these right here are the y's. The negative 3 and the 2, that's where those came from. Because we're finding the x determinant now, we need to replace the x column with the actual answers to the system. So instead of putting negative 3 and 2 there, I'm going to put negative 4 and 1, because that's the answer to this system. Or that's the answer to each of those equations. Okay, the y's are going to stay the same. So the y's are still 2 and negative 3. And then we find our determinant. Negative 4 times negative 3 is 12. Minus 2 times 1 is 2. 12 minus 2 is 10. So this is 10. And now we can find the x. X is 10 divided by 5. And that is equal to 2, which is our first solution. The final thing we need to do is find the y determinant. And again, this time, because we are finding the y determinant, I'm going to keep the x's the same, negative 3 and 2. But I need to replace the y column with these answers. So negative 4, positive 1. That diagonal multiplies to negative 3, minus negative 4 times 2 is negative 8, and minus negative 8 is like plus 8, and that equals 5. So the dy is 5, and to find the actual y value, you take the determinant of the y divided by that main determinant, and you get y equals 1 as your answer. So the x is 2, and the y is 1. And we can obviously check by plugging those into the equation, just to check that they work, and they should work. Alright, let's do one more of these. So let's find these three. Let's start with the main determinant. The x's are 2 and negative 1. The y's are 3 and negative 2. When we multiply that, we get negative 4, minus, if we multiply that, we get negative 3. Negative 4 plus 3 equals negative 1. So that's our primary determinant, our main determinant. Let's find now the x determinant. So this time we're going to replace this x column with these answers. So 1 and 0, and the y's are 3 and negative 2. Okay, 1 times negative 2 is negative 2, minus, that equals 0. So negative 2 minus 0 is negative 2. And then finally, the last thing we need is our y determinant, which is going to be right here. And this time we'll replace, because we're finding the y determinant, we'll put those numbers in for the y column. The x's are still going to be 2 and negative 1. Okay, 2 times 0 is 0, minus 1 times negative 1 is negative 1. So minus negative 1 is like plus 1, and we get that. So what's our final answer? Okay, our final answer is x equals the x determinant over the main one. The x determinant is negative 2, the main one is negative 1, and negative 2 divided by negative 1 equals positive 2. The y equals the y determinant over the main one, and the y determinant turned out to be 1, so 1 over negative 1 is negative 1. So our answer should be positive 2, negative 1, and it is. Alright, last section of this chapter is on using inverse matrices. So what we have to do here is we need to be able to find the inverse, and here's how you find it. The inverse is always 1 over the determinant, and then we need to switch these diagonals, and we need to negate these diagonals. So I'll show you what that means. Let's find the determinant first. The determinant of this would be 2 times 12, 24, minus 3 times 6, 18. 24 minus 18 is 6. So we know our determinant is going to be 1 over, our determinant is 6. So our inverse will be 1 over 6, okay? Which means these are both wrong. Okay, then we need to switch the first. If I switch 2 and 12, the 12 now is here and the 2 is here. And then I need to negate this second diagonal. So if I negate 3, I get negative 3. And if I negate 6, I get negative 6. And it looks like that is the right answer. Alright, let's do this one. This is again going to be 1 over the determinant. Switch the first, negate the second. Let's first switch these. So if I switch them, negative 10 is there and 1 is there. And then let's negate these. If I negate that top one, it's negative 1. If I negate the negative 1, it's positive 1. Okay, what's the determinant? Because that's what goes here. The determinant is going to be that multiplied, which is negative 10, minus this multiplied, which is negative 1. Negative 10 minus negative 1 is like negative 10 plus 1, which is negative 9. And that's what goes right here. So this is the determinant, and you can leave that number outside. You don't have to multiply it in, as we'll see why with these two last problems. Okay, so the last two problems we're going to solve using inverse matrices. This, let's just call it a letter. Let's call it matrix A, and we'll call this one B. We want to solve for x right here. So in order to do that, you see what's being done to x, and you do the opposite. X is being multiplied by matrix A. The opposite of multiplying by matrix A is multiplying by the inverse. These will cancel, and then whatever I do on the left side, I have to do on the right. So I basically need to find out what this matrix is, what this inverse matrix is. Let's start by switching these, because that's how we find the inverse, and negating these. If I negate negative 1, I get this. If I negate negative 8, I get this. The determinant is those things multiply, which is 6, minus these things multiplied is 8. 6 minus 8 is negative 2. Okay, so that's my inverse. I need to find out what this is, though. So I'm going to take that, and I'm going to multiply it by matrix B. I don't need to do that on this side, because I already know that when I multiply by A inverse, these will cancel, and it's just going to leave me with x, which is what I want. Okay, so this is our B matrix. So I'm going to put this right here. Let's first make sure it's possible to multiply this. This is 2 rows by 1 column. This is 2 rows by 2 columns. These numbers are the same, so we can do it. And these numbers here are going to give us the dimensions. So the new one will be a 2 by 1. And I'm going to keep this negative 1/2 right here, just to make it easier for us when we're multiplying. Okay, so let's do this. So we have first row, first column. Here's the first row, here's the first column. Negative 1 times negative 24 is 24. And 1 times negative 36 is negative 36. That's a plus negative 36. Okay, then we have the second one. The second one is going to be second row, first column, which is right here. 8 times negative 24 is negative 192, and negative 6 times negative 36 is plus 216. Let's just clean this up a little bit. 24 plus negative 36 is negative 12, and negative 192 plus 216 equals 24. Negative half of negative 12 is 6, and negative half of 24 is negative 12. So that should be our final answer, unless they made a mistake, and it looks like it's correct. Alright, I think we have time for this last one right here. Let's do the same thing. Let me clear off these annotations so we have more space here. Same thing, this is matrix A and this is B. We need to find A inverse, so those will cancel, and we'll multiply these together. So we need to find A inverse, and we need to multiply it by B, which we already have. Okay, and this, since these are the same dimensions, we already know that this is a 2 by 1, this is going to be a 2 by 2. So our final one should be a 2 by 1. Okay, so let's double check. Now all we need to do is find A inverse, 1 over the determinant. The determinant of this is 36 minus 30, which is 6. So that number goes right here. That means it's going to go in front right here also. And then if we switch these, we get negative 9, negative 4. If we negate these, we get 3 and 10. So let's multiply this. This is first row, first column. So there's the first row, there's the first column. Negative 9 times 10 is negative 90. 3 times negative 34 is negative 102. So when you multiply those together, you get negative 192. And then here's the last one. We have second row, first column. 10 times 10 is 100. Negative 4 times negative 34 is, what is that, 136, I believe. When you add those together, I think you get, unless I made a mistake there, 100 plus 136. I think that's right. But for some reason, that's not working out evenly. So let's just double check that we did not do something wrong here. So, oh, you know what? Here's the problem. This is supposed to be a negative 10. So that's negative 100. That actually just equals regular 36. And that means the top one should be negative 9 times negative 10 is positive 90. So that's supposed to be and negative 12. The last thing is 1/6 times negative 12 is negative 2, and 1/6 times that 36 would be positive 6. Alright, so that is the end of chapter 3. That's on inverse matrices. Hopefully it helps to clarify some things.